Hello, and thanks for joining us for this Spotlight Series segment. I'm James Green, partner at ActualTech Media. I'm the VP for content. And today we're going to talk about one of my very favorite topics, which is storage. I love to talk about storage. And my guest today lives and breathes storage in that space. And so we're going to have a fun chat. Before we get started, I'd like to introduce our guest, Josh, and the company Lightbits Labs. So, Josh, I'm going to ask you to just tell us a little bit about yourself and Lightbits before we get started.
Sure. Thanks very much. Very happy to be with you today. It was a lot of fun getting the message out. And as we said, my name is Josh Goldenhar. I'm the VP of Product Marketing for Lightbits Labs. And Lightbits Labs is the developer of basically the NVMe over TCP protocol, working with standards committees to go ahead and get that standardized. We went ahead and not only standardized or worked to help standardize the protocol, but have a full product, which is a software-defined solution for storage that gives you NVMe performance while giving you the kind of features that you're used to in traditional all-flash arrays.
So let's just get this out of the way for the folks that are going to be pained trying to figure it out. It's pooled NVMe, remote, and uh, deployed in some very special ways. And so we're going to dig into that. So the first thing is you mentioned NVMe over TCP, which is an important design choice. Can you talk about what NVMe over TCP is and why it's important that the system is based on that?
Sure, absolutely. So NVMe, hopefully folks know, is just this lightning fast, very low latency media that you put inside a server. And almost as soon as it was announced, not even when products were out, people were thinking about how to use this very, very fast media remotely. And so NVMe over Fabrics was developed. But NVMe over Fabrics supports multiple different fabrics. And fabric here is things like fiber channel, Ethernet, InfiniBand. And then on top of each of these fabrics, you run a protocol. So of course on fiber channel, you run fiber channel protocol in NVMe. On top of InfiniBand, you can also go ahead and speak an RDMA protocol. And in the case of Ethernet, the first one to come out was Rocky. Rocky is RDMA over converged Ethernet. So all of these things basically took what were these different protocols and ran them on top of a different fabric, but they required, it's not specialized NICs, they required NICs from only a handful of vendors, and that handful may only really be two vendors. So that is, you had to have RDMA capable NICs, meaning you can't use discrete NICs. You had to use discrete NICs, excuse me, not the NICs that just came with your servers. We recognized early on that what people really wanted was ease and convenience. They wanted to use NVMe. They wanted to get maximum utilization out of it, but they wanted to use a protocol that is ubiquitous. It's available in every single data center. You didn't have to add special NICs. You didn't have to gain new knowledge on how to do a new protocol, such as Rocky. So we worked very hard with the standards bodies and nvmexpress.org to go ahead and standardize NVMe over TCP. And the company actually wrote the code for the NVMe over TCP initiator and targets that was contributed to kernel.org. So we have this belief that it should be standard, it should be easy to use, and it should be something that everybody knows and loves. And to put a finer point on it, if you like iSCSI today because it just works so well and it's so easy and you don't have to change your network, but you wish it was higher performance, that's basically what you can get with NVMe over TCP.
Cool. And so then to piggyback on that idea of being able to um, use what you have or what you're comfortable with, the next important point I think about the solution that you mentioned is that it's software defined. So as opposed to utilizing specialty hardware, you talked a little bit about the NICs. The LightOS software delivers everything that we're going to talk about on what is more or less commodity hardware, and you can sort of choose what you're comfortable with. Is that right?
Yeah, absolutely. Early on, I've actually had people tell me, wait, you guys, you're a hardware company, right? Because we had this accelerator card called Lightfield, and we still offer that, but you don't have to use it in every kind of server. Um, it's really a choice on whether you want to accelerate certain things with compression and some parity calculation algorithms. Um, in general, we want to be completely software defined, such that you take the server of your choice, It should have a minimum of 8 NVMe drives. And you put that into a cluster. Our cluster size is a minimum of 3 servers. So you want to start at least with 3 servers, 8 drives each. And then from there, you basically pick what's right for you. If you want to only use 25 gigabit interfaces on your clients, that's fine. If you want to use 50 or 100 or even just 10, because we're NVMe over TCP, we literally will work with any Ethernet TCP capable NIC, even if you had a 1 gigabit NIC. So it was important to not only have a protocol that was ubiquitous, but to run on essentially any platform, giving customers the ultimate in flexibility to exactly set up their storage systems to meet their needs, whether that's for high capacity or high bandwidth or high IOPS, or actually any combination of the three.
So one of the reasons it's important to sort of pool and remove storage from the servers that it has been in a lot of cases, NVMe trapped inside the server, is the same
Mm-hmm.
reason it was so important that machine virtualization came along, and that is utilization. In a lot of cases, either performance or capacity is way underutilized when it comes to NVMe inside of servers. When we can bring that outside the server and aggregate it, pool it, and then use just what we need from that pool, we're able to be a lot more efficient. Do you have any other thoughts, or could you speak to the idea of efficiency when it comes to storage today?
Yeah, absolutely. You're hitting the point dead on. Just as when you had processors and or even memory in servers that was underutilized, virtualization came along and fixed that. It allowed you to get much higher levels of virtualization. And we see that marching on with containers as well, putting multiple containers on the system. So this is really no different. If you put your NVMe inside each server, you do enjoy very, very low latency. But when you have multiple drives and each drive can support 500,000 plus IOPS, you simply can't consume all the IOPS on that one system. As you add additional drives, you're adding more capacity, but you're not actually able to achieve any more performance. Likewise, in customers that we survey on a regular basis, they tell us they're generally from 15 to 25% overall utilized. That is, when they put drives on every single application server, uh, they spread them all out. They find on average there are maybe only 15 to 25% capacity utilized over the entire aggregate amount of capacity. And that really is terrible when you consider that these drives are expensive, relatively expensive. So you want to get the best utilization. By taking the drives out of the servers and putting them as pooled storage and then pulling out only the capacity you need. And when you add on to that LightOS also is thin provisioned and has snapshots and clones, it means basically that you can provide an 8 terabyte volume over the network. And if the customer or that customer's customer only ever uses a mere fraction of that drive, you've not consumed all that flash on the back end. It's being utilized by potentially other customers. And so you get much, much higher aggregate utilization rates across your flash pool.
Got it. Okay, last question for you today is about performance. So one of the
Mm-hmm.
arguments that a lot of hardware providers will make is that there's a certain level of performance that you just must have an ASIC or a specialized accelerator or something to achieve. Um,
Mm-hmm.
and one of the beautiful things about the platform, as you're describing it, is that it's entirely software. And I believe it's still high performing. Can you speak a little bit to performance as it relates to that trade-off between software and hardware-based systems?
Right. And I think you're actually talking to part of the beauty of the system we provide. Being entirely software defined, the first thing you can choose is the processor you use. So if you want to use a $500 processor per socket, you will be limited in the top end of performance you can get. But if you want to up that to a $1,500 or a $2,000 processor per socket, you're going to get far more performance because the more cores on there acting as your part of your storage engine are going to get you higher levels of performance. What we can offer is not on the very high end of processors, but in testing we've done on the Intel platforms with the Xeon scalable processors, we can get as high as 3.9 million IOPS out of a 20, I think it's a 28 core processor. And that might be pricey for some folks. If you only need 2 million IOPS, and I hope people know I'm being facetious here, if you only need 2 million IOPS, you can use a kind of middle of the road gold processor and get that amount of IOPS and very, very high bandwidth levels, to 10 gigabytes per second of bandwidth per target server. And because we're a clustered scalable solution, the aggregate to your cluster is going to be basically equal to that same performance and how many systems you go ahead and put in, because we're linearly scalable. So if you can get 10 gigabytes per second from a single host, if you go to the maximum of 16 nodes, you're going to go ahead and get that 160 gigabytes per second of aggregate bandwidth. So you get to choose basically exactly the performance you want by doing the investment in that. You're tuning the size of the processor, the number of cores, maybe even the amount of memory you put in the system. And then if there are certain things you really need more acceleration, and this comes in our compression. If you need the latency to be extra, extra low with compression, you can go ahead and add our light field card. And then we're using an FPGA rather than a special ASIC. We're using an FPGA with special code to go ahead and further accelerate the compression algorithms and give you lower latency, even with highly compressible data. And that'll affect both reading and writing of that. So you have all the different options before you, rather than just saying you have to have a custom ASIC and you have to have custom hardware.
Another way that it seems like you could probably tune that is the drives you put in the system, whether you're going to have a workload that's particularly read heavy or write heavy. I know you can front end some of those writes with Optane. So again, you can custom tailor this system to exactly the sort of workload you anticipate running on it.
Yeah, most definitely. And that's what customers really like. Some have chosen to stick with TLC NAND at much higher drive writes per day because their workload is very, very write intensive. And then, of course, we have others that have realized that they can actually use QLC. They thought they were going to have to use more expensive NAND, but they're actually using the Intel QLC drives because they get them at a much lower cost. And because we reorder the writes and work with QLC in a very special manner, we actually get higher aggregate write performance than the customers thought they could. And because they don't have to worry about wearing out the media, because we get to 5 times more endurance with QLC than if you were to write to it just locally. Because they don't worry about wearing out the media, they end up using QLC where they thought they couldn't use QLC before.
Well, Josh, it's great to have you on this Spotlight Series segment. If I don't cut myself off, I'll be asking questions about Light OS and Lightbits all day. So we got to wrap it up for now. But if people are listening and they want to dig in further, learn a little bit more, what would you recommend they do as a next step?
Well, definitely give us a visit at lightbitslabs.com. Website, of course, there on the screen. And there's all sorts of materials there. You can also send an email to info@lightbitslabs.com if you want to do that. And either way, you can either find information. There's also lots of materials on Bright Talk. We do things there, as well as some YouTube. But if you start off at lightbitslabs.com, you'll find all the information you need.
Very good. Well, Josh, thanks again. And to everybody watching, thanks for joining us.
Okay, and really appreciate it. Thanks very much. It's been fun.